Rigid motions and congruence. Number 19 to 27. Is quadrilateral ABCD congruent to quadrilateral MNPQ? If so, explain using rigid motions. If not, explain which corresponding parts are not congruent. So the behavior of one point is the behavior of all. So what we're going to do is we're going to analyze what's happening from A to point M. So if we look at number 19, here's A and here's M, so it looks like a translation is occurring. So when we take point A, we're going to translate 1, 2, 3, 4, 5, 6 units to the right, and then we're going to go up 2. The rectangles are supposed to match, but in this case it doesn't because AB is not congruent to MN and DC is not congruent to QP. So in number 19, we're going to say that the quadrilaterals are not congruent, and that's because AB is not congruent to MN and BC is not congruent to QP. If we look at number 20, we have ABCD again, and if we notice, A looks like it's going to translate to M. So let's test the theory out. If we go 1, 2, 3, 4, 5, 6 units to the right, notice there is a match. So we're going to say that ABCD is congruent to MNPQ by translating right 6. If we look at number 21, here we have ABCD again. Notice the A matches up with the M here. The only way that can happen is through a rotation. So if we put our pen at the origin here and we rotate 180 degrees, notice the A is matching up with point M, N is matching up with the B, P is matching up with the C, and Q is matching up with the D, which is what we want. So that means the quadrilaterals are congruent by rotating 180 degrees about the origin. If we look at number 22, again, we have point A here, but instead of being here for M, M is here. The only way that can happen is if we have a reflection. So if we take ABCD, we flip it, and notice that we have a match through a reflection over the y-axis. And that's what would be the reason for the quadrilaterals being congruent. If we look at number 23, in number 23, A and M looks like it's going to translate. So when we translate 1, 2, 3, 4, 5, 6 units, notice we're supposed to have a match, but we don't. It turns out that AB is smaller than MN and DC is smaller than QP. So what that means is ABCD is not congruent to MNPQ, and that's because AB is not congruent to MN, DC is not congruent to QP. If we look at number 24, ABCD, notice point M, so we can translate 1, 2, 3, 4, 5, 6. Notice we have a match. So in that match, we're going to say the quadrilaterals are congruent by translating right 6 units. Number 25. Again, we have parallelogram ABCD. Notice point M is located here, point A is here. The only way that can happen is through a rotation. So we're going to try and rotate about the origin. Notice 90 degrees doesn't work, but 180 degrees does. So A matches up with the M, B matches up with the N, P matches up with C, and Q is matching up with D. So what happens here is the quadrilaterals are congruent by rotating 180 degrees about the origin. If we look at number 26, again we have parallelogram ABCD. A is matching up with M, the B is matching up with the N, C is matching up with P, D is matching up with Q. So the only way this can happen is through a reflection. So if we were to take this parallelogram here, match it up, notice it is a match. So we can say that the quadrilaterals are congruent by reflecting over the y-axis. Number 27, this is very interesting. Looks like the only way this can occur is through a rotation because A is here and M is here. So what we're going to do is we're going to translate A towards M. So we're going to translate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we're going to go down 3. 1, 2, 3. So at this point here, what happens is we're going to rotate 90 degrees clockwise. We're supposed to have a match, but we don't. And it's because of the same problem. AB is shorter than MN, DC is shorter than QP. So ABCD is not congruent to MNPQ because again, AB is not congruent to MN, DC is not congruent to QP.